Okay, hey everybody. We started working on 5.3 Voronoi diagrams earlier today, and we defined it, we labeled it, and we looked at some examples. We did not get to the simple Voronoi diagram using four seeds. So I'm going to do that now. So in this diagram here we have a bunch of seeds, and we can see that between each seed is a perpendicular bisector, and with the three closest seeds we can see that those perpendicular bisectors intersect at a vertex. So what is not drawn here are the segments that are getting perpendicularly bisected. So we can see what is called Delani Triangles between all of these seeds. So if I take the three closest seeds, for example, right here, this would be called a Delani triangle, and I would get a perpendicular bisector here that I would construct. I would have another one right here, and I would have another one coming in right here between these two. That'd be a right angle. Okay, but since so when I find my intersections on these, it actually kind of takes it outside a little bit of this long edge of the Delani triangle, and these are my my three intersections from my boundaries. I would also do it with this triangle right here. So here's this perpendicular bisector this side, and then the perpendicular bisector on this side right here is this line here. But since these are intersecting on this side of the bisector, we don't draw it all the way through, and so we end up erasing that part of the bisector. So we're trying to find where the three perpendicular bisectors intersect. It could be outside one of the triangles, or it could be inside. We just have to see where they all bisect. In this case right here, on this triangle, we see that they intersect inside the triangle. So perpendicular bisector between these two, perpendicular bisector between these two, perpendicular bisector between these two. Oops. Now, recall that the perpendicular bisectors intersect at Circumcenter from the last section, right? So this is actually the Circumcenter, and a Circumcenter is the place from which we can circumscribe a circle. So from this center here, these seeds right here will actually be on the circle, right? I hope you remember when we did that. So if we get an acute triangle, expect to see the intersection here of the vertex to be inside of the triangle. In this case right here, we had an obtuse triangle, and so the intersection ended up being outside of the triangle. Okay, so that means our circumcenter is outside the triangle, and when I draw my circle, see those 3 points are on that circle right there. So keep that in mind when you're trying to figure out your boundaries. See if you can recognize what kind of triangle you're dealing with, and don't forget, a right triangle, the intersection would be on one of the sides. In fact, it would be at the midpoint of the hypotenuse. Okay, so if you happen to get a right triangle, I don't see any here that quite work. Maybe this one a little bit, not quite, still cute. Okay, so we're gonna find our boundaries here for our Voronoi diagram with these 4 seeds. And so the first thing to do is to make the Delani triangles. So what you're gonna do is you're gonna try to find the 3 points that are closest to each other. So let's say these 3 right here. So I'm just gonna make a light line. We really don't want the triangles in our final. They're just helping us get the perpendicular bisectors. So we got that triangle, and we have this triangle right here that looks like we can use. And we also have, I mean, you could see we can have a triangle that goes like this, but these 2 points, this point right here is farther away from this point than these 2. So we're really not going to need to draw that one. We could draw it, and then if we do a perpendicular bisector, you'll see, oh, that one is not even, it's going to be outside the boundary anyway. So let's just take these 3 right here, and what we're going to do is I'm going to do these 2 points first. Maybe I'll label them. So we've got A, B, C, and D. So let's find the perpendicular bisector for A, B. And so with my compass, I could make 2 arcs, and I didn't make that large enough. I got to make them at least halfway. Just trying to make it small so it wouldn't be too difficult to see. So let's try this. We got that one, and we've got that one. They're my 2 arcs, and I'm going to make my perpendicular bisector. Okay, it's like that. Just erase a little bit here of the extra stuff. Alright, now let's get a B to C. So anywhere along this line tells you where it tells you that the points along this line right here are equidistant from C and B, right? So we're trying to find the cells, and the area inside the cells tells us that those points are closest to the seed. So far I have this intersection here. So this boundary and this boundary, and so we got this that is a boundary right here with this seed. So B is the seed, and so far this is the cell. Okay, now I gotta do let's see, what do I have to do now? I'm gonna do let's do CD here. And it's been a while since I've done these, so I'm trying to refresh my own memory on how we find these boundaries. Okay, so perpendicular bisector between C and D, like that. And I also want to do AC. That's what I should have done next. Should have done AC next. Okay, so the midpoint that is perpendicular, so the perpendicular bisector here, should go right through this vertex here that we already have established. So let me extend that, and let's get a. Alright, so I've got this point here, and this one, it should go right through that vertex. So I'm just snugging up my pencil, and then there we go, there's that line. Okay, so I have this boundary here now too, and now where does this end? Okay, so I already made the perpendicular bisector for CD, and it comes in right there. Okay, so this boundary here is the one for C, right here. This seed here has this boundary. And now, what do I need? I need to figure out the boundary here between D and A, and then we're done. Let's see. So we could also, I think some of you maybe don't have a compass, okay? So what you could do also is you could find the middle measuring. This is certainly not as classic, but we could do it. So this is 6 centimeters, so half of that would be at 3. So there's my midpoint. And then I could make a perpendicular here, putting my midpoint at the center of my protractor, lining up to 0, and then getting my 90. There, do you see that? That's 90. And so I can make a perpendicular there, and then look right here, do you see this is the intersection from the other two seeds. So okay, there are my boundaries. Now let's get out my colored pencils and so I have 3 points, or 3 segments that intersect at this point, and 3 segments that intersect this point, vertex. So here is the cell, and this is an unbound cell here. I need more seeds if I'm going to get some more boundaries. Okay, so that is for that seed, and that was for A, and I don't know, yellow. B. Let's get blue. Point C. And then green. Alright, so you can see 4 seeds, 4 cells, 2 triangles, 2 Delani triangles. And see the triangles, I don't want the triangles. I need the triangles to make the diagram, but they're not part of the boundaries. Alright, and that's it. Okay, so we got 2 vertices here from 2 triangles, and we have 4 seeds, and we have 4 unbound cells. The next thing we're going to look at, we're going to work on this more tomorrow, is this map of Crozet. And so this is the town closest to your school. And I have put some seeds in here, A through I. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, seeds, and these seeds are wireless transmitters. And so the idea is, depending on the location, which cell location would you want to connect to that would be the closest. Okay, so if you were at Crozet Park, which seed, or even maybe a little bit more difficult to determine, if you're at the Crozet Library here, which wireless point would you use? Would you use wireless G or D or maybe C? I think C looks a little bit further away. Maybe it would be G. But if we make a Voronoi diagram on this, we could easily create a map and you can find your location and know exactly which cell location is or wireless location is the closest. So the first thing we would do here is we would just start making our Delani triangles. So we find 3 seeds that are the closest and we just start making our triangles. So then we're going to work from there, and we're going to do all of those, and then between each side on these triangles we're going to find the center and make a 90 degree. And it very well might be easier to use a protractor here instead of making construction, because it just makes it so we have less confusion on the map, because the more arcs and things and lines we have on it, the more confusing it will be. Alright, so I've got this one. Now this is an acute triangle, so expect the center, the circumcenter, to be inside, and it's going to be, and we're going to be able to find our the vertex inside of the Delani triangle here. Alright, so right in here somewhere they're meeting, and then I'm going to get measure BH. Let's see here. I think it's okay to use the protractor. Certainly is a lot more classical to use the compass. So right here I've got my intersection. So if you have the store finishing touch, or at this store, your closest wireless point would be the C to A, because it's inside this bounded area here. And so we wouldn't really want these triangles anymore, so we can get rid of those, and we could shade in maybe this color. Okay, so that's what's on tap for us in the next day or so. Alright, let's get this video up on the site. I'll see y'all later.